All right, so let's do it. Let's do an example of a problem. You got a problem, Igor?
I got a problem.
Okay, what do we want?
1 over
1 over
x over 1
x over 1
plus 2.
Now, what problems like this? Well, how do you feel about this problem? Is it scary?
It makes me feel like I suck at math.
Oh no! And you do suck at math. I mean, that's good for you to feel that way.
Yeah.
Well, how are you going to deal with this? I mean, this doesn't look like a fraction addition problem.
I don't know, because I suck at math.
Well, all right. So, is there a way that you could turn this into a fraction addition problem? Are you stuck, Igor?
I'm stuck.
Okay. Look, here's the problem. The thing that's scary about this is that we put that fraction addition problem, but we put it on the underside of a fraction, which really sucks. So when we see a problem like this, instead of looking at the big thing, let's do this by the salami. Have you ever heard of the salami method, Igor?
No.
Really?
No.
How long have we been hanging out for a long time?
A couple of years.
And you still don't know the salami method?
I don't know the salami method.
The salami method is, how do you eat a salami?
You slice it.
You slice it. Nice, thin, tasty, delicious slices.
Easy slices.
Easy to chew.
Easy to chew.
All right. So let's take this problem and turn it into a salami problem and slice it and dice it. So instead of working on the big thing, let's work on the small thing. So let's do that addition of that fraction under there and see how that's going to work out. This is scary when you put things under a big denominator like that. That's really it sucks.
Confuzzling.
It's confuzzling. All right, so let's leave the 1 over on the top and just work on the bottom. Now, how can I add the x plus 1 over x over 1 plus 2?
Well, see, what you have to do is you have to have the same denominators, right? So 2 is equal to 2 over 2.
2 over
1.
1.
2 over 1.
So I got x plus 1, x over 1, sorry, plus 2 over 1. That's looking better.
And then you would equal 2 plus x over
x plus 2
over 1.
Over 1. Now what am I going to do with that? Igor.
Well, you would, because the opposite of division is multiplication.
By reciprocal.
By the reciprocal.
Right.
Such as when one person punches you, you punch them back.
That's reciprocation of a different sort.
Oh, okay.
That's reciprocation of a different sort.
That is reciprocation of a different sort.
What you're talking about is this. If I have a fraction that looks like this, a over b over c, that's the same as a times c over b, right?
Yeah.
So if I take this idea and put it up here, I got 1 times 1 over x plus 2.
Which is the same as 1 over x plus 2.
Which is the same as 1 over x plus 2.
And isn't that the same as negative x plus 2?
That is not the same as negative x plus 2. This is the same as, if we're gonna remember some exponentials, this is x plus 2 to the minus 1 power.
Oh, okay, I knew it was something.
Yeah, something
negative.
Cool like that. What's that funny thing? Did I make that mark there?
Yes, you did.
How did that happen with my little pen?
Because it's such an expensive thing.
It's such an expensive thing. It works that way.
Yeah.
All right, let's get rid of those strokes. Okay. So there it is. 1 over x over 1 plus 2 over 1 ended up being 1 over x plus 2. Circle it in red. Okay. Whoops.
Oh no.
I erased. Can I undo the erase?
You can totally stop and mess it up. Oh. Aha.
Nice. Get the pen. Control Z. 1 over x plus 2. Okay. Let's do one that's a little bit harder. Move to new note. How about this? Bing! New note. Did I go to a new note? Yes. Yeah. Okay, let's try this one. How about in blue? 1 over x plus 2. This is another case where we got this crazy thing all over the one big fraction. What's so funny? Why are you laughing?
I'm not laughing.
You're laughing.
I wasn't laughing.
You laughed.
I didn't laugh.
All right, give us a good one.
No, because it takes a while.
Okay, you gotta work it out.
I'll swallow the air right now.
You swallow the air, and I'll do this. So we've got this fraction over here, and again, by the same thing that we were doing before, we're just going to simplify that bottom part. So let's simplify the bottom part, and we will end up with 1 over. Now, 1 over x plus 2 is the same as 1 over x plus 2 over 1. And that's 1 over, let's see.
Oh, man.
It's lame.
It didn't come up yet.
You're laming.
Well.
Okay, check this out. I'm going to pick a different color. What color? Pink. Remember how this works? Oh, nice! Nice!
No!
Who's your daddy? Okay, 1 over 1, let's see. That's 1 over 1 plus 2 times x. 1 times 1 plus 2 times x. It's 1 plus 2x, are we right? Over x times 1.
Which is x.
X times 1. So we got the whole thing. Now remembering what we did before,
That was just an x.
we got 1 divided by a big fraction, which is the reciprocal of that big fraction. We get x over 1 plus 2x.
Wow.
You like that?
Yeah. And couldn't you simplify it more because of the x and the x?
Can I simplify this? Oh, nice question. Excellent question. Can I simplify that some more? What would you like to try to do?
Well, wouldn't you divide the x by the x and then you get...
Oh, you mean like x plus 1/2? Is that kind of what you're thinking?
Huh?
Well, so you said this is the same as x over 1. Whoops.
Whoa.
Whoa. X over 1 plus x over 2x. Is that what you were thinking? And then you could cancel out the x's?
Yeah.
Cancel out the x there and the x there.
Mm-hmm.
To get x over 1 plus 1/2?
Yeah.
Plus 1/2.
And then if you make that 2, so you multiply it by 2, it would be 2x over 2.
Wait a sec. Let's just ask ourselves about this. Let's ask ourselves about this question right here. Can I take this and can I divide the denominator? Because I know that if it were the other way around, if I were doing something like, if I were doing this upside down, I want to start erasing. If I were doing this upside down, if I said 1 plus 2x over 1 plus over x,
oh.
I know that's equal to 1 over x plus 2x over x.
So then you won't be able to do it.
Well, this is okay. No problem with that. In fact, that is so cool, that's going to get the happy face. Okay, that's good. This big, bad, blue, sad face. No, can't do that.
And why is that?
Well, give yourself a test. Here's a way to check whether an idea that you have is a good idea or one that's not going to work. Try a number. Let's let x equal 1. Let's say x equals 1. Okay?
Mm-hmm.
Then if I have x over 1 plus 2x, then x over 1 plus 2x would be, I'm going to come back up here in blue, that's the same as 1 over 1 plus 2 times 1. Right?
Yeah.
That's the same as 1/3, right? 1 over 1 plus 2 is 1/3. Okay, now the question is that the same as 1... Whoa!
Whoa, my goodness.
Is that... is that the same as 1 over 1 plus 1/2?
No.
Okay, so there's a numerical demonstration that this idea of splitting the bottom doesn't work. All right, so there's a quick example of how to see addition of fractions in a problem that looks harder than that. Let's go back and look at the original problem. See, we had this problem here, and what we recognized was that we're dealing both with addition of fractions and we're dealing with reciprocals. We have not done a YouTube on reciprocals yet. We'll have to do that.
Yes.
Okay, but for now,
We'll do it next.
there it is. Say goodbye, Igor.
Bye. Bye.
Goodbye.
Bye.
Goodbye.